Hey kids, welcome back to Mr. Murray's Math Land here. Today we're talking about arithmetic sequences. And an arithmetic sequence, as you hopefully know if you're watching this video, is a sequence in which the terms uh, are a common difference apart. In other words, they increase or decrease by the same amount each time in a linear fashion. So in this problem here, we're asked to write an explicit definition for the arithmetic sequence where a sub 1 is 7. The first term is 7, and d, the common difference, is 3. So the general formula for a sub n for the explicit definition is always the first term, a sub 1, plus that common difference times n minus 1. So that's something you've probably learned or are familiar with. I know a lot of times we do that in Algebra 1 even, because it just relates to linear functions. It's just the equation of a line presented in a different form. So for this problem here, it's pretty straightforward. Just showing you how it works. You can take the first term, which is 7, and if the common difference is 3, that would tell you that the terms are going up by 3 each time. So that would be 7, 10, 13, 16, etc. So taking d times n minus 1, and most times we're going to simplify that by distributing 3. So that would be 3n minus 3, and then combining like terms. And I really like to do this just so that when you combine that 7 minus 3, you get plus 4. I like to really just tie this back to that it really is just the equation of a line presented in a different form, where this would be the same thing if you were to graph it as y equals 3x plus 4, where the slope is 3, that's the amount it's increasing each time, and the y-intercept is 4. Okay, so one more problem here with this. It's just to show, a couple basic things here. And so write the explicit definition for this, where we're showing you the first few terms of it. So this is a sub 1, this is a sub 2, this is a sub 3, just to get you comfortable with that notation. So we have that a sub 1 is 5, and the d, the common difference, is what is this going up or down by each time? And 5 to negative 1, that goes down by 6. Negative 1 to negative 7, that goes down by 6. Negative 7 to negative 13, that goes down by 6. And if you ever can't just see it and do it in your head, it's called a difference, because you take any term and you subtract the previous term. So negative 1 minus 5, and you'll get that negative 6 there. So now, knowing those two things, that's just using that same format we spoke about a minute ago, where a sub n would be the first term plus that common difference times n minus 1. So for this arithmetic sequence, the first term was 5. The common difference was negative 6. So that's going to be minus 6 times n minus 1. And we'll distribute that. So that will be minus 6n plus 6 when you add that. When you multiply negative 6 times negative 1, combine your like terms, and you will get negative 6n plus 11. And there we go. And just to, again, tie that back to Algebra 1, which, everybody, is pretty comfortable with at this point. So that we're just kind of showing these relationships in a slightly different format. That would be the same thing as y equals negative 6x plus 11. 11 being the y-intercept, or the value when x is 0. So there are a lot of people who will kind of just write these formulas just by looking at it, and they'll say, look, a sub 1, that's 5. The y-intercept would sort of be the 0th term. And what would the 0th term have to be if we're going down by 6 each time? Well, what would that previous term have to be to 5? That would be 11. So I definitely know some students will just, kind of grab that and maybe do a lot of this stuff in their head, say, well, that's the b, the slope is negative 6, and I'm just writing the equation negative 6n plus 11 there. So, you can use it as a check, or just to kind of solidify your understanding of this. But there we go. There's how to use the formula and how to logically make sense of it, hopefully. All right. If you have any questions, just hit me up.